the room condition or room temperature, it should not be affected. Then humidity effect should not take place. There should not be any corrosion or erosion. Then size matters, compatibility of the size. Then overrange protection should also be provided. Then susceptibility of electromagnetic interference, rigidness, that it should be hard and it should sustain, that is your robustness. Then self test capability, it should have the self test capability. Then and then only we people will come to know that yes, this instrument is providing us accurate output. Now economic factors which are supposed to be considered while choosing a sensor, that is cost. I have already discussed about that one, that cost should not be more than that of the product. It should be easily available and it should have a good lifespan. Sensor characteristics, that is, it should be sensitive. It means that we are going to see all these characteristics in depth, but as an example I am specifying, as I have provided a input and it should provide me a output instantly. Then in some of the cases, if my output generated is having the delay, at that time the resultant output which is going to be generated, that resultant output will be hampered or accuracy may not be maintained in that particular case. So we have to consider the characteristics that are enlisted in the sensor characteristics. Means it should be sensitive, it should have a sustainable range, it should be stable, it should have repeatability, it should be linear, there should not be any error, response time should be there, and it should provide a frequency response. All these parameters we will go in depth while studying characteristics. Now what is the need of sensor or transducer? General speaking, all the devices recently, whatever we people are using, you people are having the cell phones and they are smart phones. It means that one of the example that can be considered touch screen. On what basis this particular touch screen mobile operates? Actually, it consists of a sensor, it consists of a transducer. If that sensor or transducer fails, automatically the operation of that particular device will hamper or it will not work. So sensor perceive, they are embedded in our bodies, then automobiles, aeroplanes, cellular phones, radios, then your chemical plants, industrial plants, and there are countless applications of the sensors and transducers. Without the use of sensors, there would not be any automation. Whatever we people are saying, we are moving towards the empowerment, and how? So over here, actually, without sensor, your automation is not possible. So for the purpose of automation, there is a need of a sensor. Now, sensor classification, that is, on what factors actually your transducers or sensors are classified. So, based on the principle of transconductance, that is exchange, that we will see in the depth, whether it is active or passive transducer. Then null deflection type of instrument, monitoring transmitting instruments, analog and digital, again inverse transducer. So transducer that converts one form of energy into another, that is electrical, physical into electrical. But in case of inverse transducer, your electrical energy is converted into physical. That we have seen. That is the actuator. Microphone example we have considered, and piezoelectric crystal is the best example in this particular case. Why this is so? Because the reason is that it can act as a transducer as well as inverse transducer. How it is so? that when we are applying a force on it, it will generate a voltage as an output in proportion to the input force applied. And if you are applying a voltage as an input, it will deform, means mechanical deformation will take. Now, first point which we people have seen, that is nothing but based on the principle of transconductor. So over here, thermoelectric or magnetoresistive, electrokinetic or optical, these are nothing but these are the means of electro transconductance or transmission of the data. Now, active transducer and passive transducer. Now, what is active? We people are commonly saying he is active, he is active. At that time, the question comes: what is the meaning of active? It means that there is a no need of external input or external supply, extra power which is supposed to be given to that particular sensor or transducer. That is called as a active. So here no extra power is required to produce the input and output. Second one, it is self-generating. That power which is required for the operation is self-generated. That's why it draws power from input applied. For example, piezoelectric crystal, thermocouple are the best example of a active transducer. External power we people are not applying for the operation of this particular one. Then passive transducer. This is the device which is drive or that requires a power for transmission of the data. Now here your resistive type of transducer or inductive type of transducer or capacitive type of transducer, they require the external power supply, and using this external power supply they are operating. So external input is required or it is necessary for the operation of the passive transducer. Then null deflection type of instrument. For example, you people have came across in the physics, you people may have studied the Wheatstone bridge, which consists of a 4 resistance in the 4 arm, and across the bridge which has been excited using some power supply, DC input, and one voltage measuring output is generated across the 2 legs. So when we try to change the resistance, the deflection of the output, which is representing the output, it takes place depend upon the unbalance of the bridge. That is nothing but it is null or deflection. When all the resistance are having the equal value, at that time it will show you null output. Whereas when the resistance value of one of the arm has been changed, at that time it will try to deflect or it will try to generate the output. Another one is the monitoring or transmitting instrument. For example, rotameter, mercury manometer, thermocouple. Voltage is calibrated in terms of temperature, RTD, common. Now, monitoring one, rotameter, or suppose we have taken an example of a petrol filling plant or petrol pump. At that time, when we people are trying to fill a petrol, we are trying to specify a quantity that has been indicated on the display. Similar is the case with the rotameter. What is the flow? Depending upon the variation in the flow, your rotameter or the float will vary, and at the upper case, we people are trying to read or record the reading. That is nothing but the monitor. And transmitting instrument, that is thermocouple. Now your thermocouple is generating a output. the input for thermocouple is temperature, and for RTD, that is also temperature. At that time, one instrument, your thermocouple is generating the voltage with varying temperature, and your RTD is generating change in resistance with varying temperature. So that is nothing but it is transmitting that particular parameter, temperature parameter, into either voltage or resistance. Now, analog transducer, digital transducer. In analog transducer, actual it converts the input quantity into a analog output, or analog output a continuous function of time. Analog is a continuous function of time. For example, if we people are taking the readings, or we people are trying to measure the output of a circuit on CRO, that is nothing but your analog output that varies with respect to time, and it is continuous one. It is not discrete one. Okay, here the example is your strain gauge, LVDT, thermocouple, with help of which we people with measure using your voltmeter or any other mean, or some display, we are trying to measure that one, and that is the continuous output which we people are getting. Then digital transducer, the example, whatever the devices that you people are using to hear this particular lecture, that one is the digital. Computer is nothing but it is the digital device, or it will produce a discrete output. It is not continuous, though it is varying with the time. But here it converts the input and electrical output in the form of pulses. That is the discrete one. That is your digital one. And inverse transducers are nothing but that converts your electrical signal into physical. So over here, this is